Students often have a hard time figuring out what to do about k-factors for exits. It's fairly straightforward that all of the kinetic energy that we have here at location 2 will be dissipated in a bunch of turbulence as the fluid exits from the pipe into the reservoir here, or any large slow-moving body of liquid or gas. So that energy will be lost. The k-factor will be equal to 1.0 because the v squared over 2g, the dynamic head, the total kinetic energy that was available in the flow here, all dissipates as turbulence. So the k-factor for an exit is always 1. But the question comes up of whether or not to include the k-factor in the piping calculation. So suppose for this piece of pipe from location 1 to location 2, we have k equal to a total of 2.3 for the other fittings in the pipe. Maybe there's a valve here and some other stuff going on. A total of 2.3 for the rest of the piping. Should the sigma k that we use in our delta HM calculation be 2.3 or 3.3? And it's really pretty straightforward. If we take delta HM from location 1 to location 2 equal to the sum of the k factors, v squared over 2g, and that's the k factors from location 1 to location 2, then sigma k from 1 to 2 is equal to 2.3. We still have v2 squared over 2g right here. Not lost yet. It's as we go from the location 2 to location 3 that we're losing all of that kinetic energy. So if we were calculating the minor losses from location 1 to location 3, then we would have the sum of the k values, and we need to evaluate that all the way from location 1 to location 3 times v squared over 2g. And the sum of the k factors from 1 to 3 would be that 2.3 from 1 to 2 plus the additional v squared over 2g that we lost between locations 2 and 3. So that's getting us from 1 to 2, and that's getting us from 2 to 3. The same kind of thing applies if you're talking about entry losses. If you're already inside the entry, then the losses have already been incurred. If you're starting outside the entry, because it's much easier to start at surfaces like this, where you know the pressure and you know the velocity 0, then you're going to have to include the loss coefficient for the entry, or in this case, the loss coefficient for the exit.